Before spring break, we started 3.7, correct? And we did a few assignments over 3.7 part 1, correct? Graphing absolute value functions. We're going to finish up those notes today. There's just a little bit left in the notes. So let's get going. So we've talked about just graphing absolute values, just using a table of values. But there's also what we call vertex form of an absolute value function. And this is vertex form right here. An absolute value function written in the form g of x equals a times the absolute value of x minus h plus k, where a does not equal 0, is in vertex form. What is a vertex? It's where it changes the direction from going from increasing to decreasing, decreasing to increasing. It's that point of my graph where it changes direction. So the vertex of the graph of G is h comma k. H comma k. That comes from our equation. Bless you. Any absolute value function can be written in vertex form, and its graph is symmetric about the line x equals h. That comes from the equation also. Any questions on that? So if we're given an absolute value function in this form, we can get our vertex from it. And that'll be one of our ordered pairs that we put on our graph. That may be the ordered pair we start with, and then we start getting points to the right and to the left of it. Does that make sense? So we'll still have to create a table of values a little bit, but this kind of helps us get a starting point for our graph. Because we know the vertex is h comma k. Any questions about vertex form of an absolute value function? Any questions? Can I move on, or are we still writing?
Still writing.
Okay, I'll give you some time. You gonna write anything down?
Oh, yeah.
Yeah, I'd probably have vertex form written down. Have what the vertex is. The vertex is h comma k. And I would know that the graph is symmetric about the line x equals h. We good? Yes, no? I heard someone say something. I didn't know if it was yes or no, though.
Yes.
Yes? Can I move on?
Yeah.
Example 3, graphing f of x equals the absolute value of x minus h plus k, and g of x equals f of ax. Graph f of x equals the absolute value of x plus 2 minus 3, and g of x equals the absolute value of 2x plus 2 minus 3. Compare the graph of g to the graph of f. So let's just look at f of x first and graph it. Is that in vertex form?
Yes.
Does that take this form right here?
No. Sure, it doesn't have the A.
Does it have the a?
Could be. Go back to the slide.
Say that again.
Go back so we can see.
Yep. Absolute value of x plus 2 minus 3.
Could be a 1.
Could be a 1.
Doesn't say.
My a value is just 1. So I do have an A value there, correct? So is that in vertex form? Yes, it is. So what's my vertex going to be? Remember, the vertex is h comma k.
2, -3.
Say what?
2 and -3.
I agree with -3. -2. It's the opposite of what the sign says, because it's x minus h. So if I plug that -2 in here, that would make it x plus 2, correct? Does everyone see that? Why my x value for my vertex is -2. So it's -2, -3 for my vertex. So there's one of my points right there. -2, -3. Everyone okay with that? So now I know where the turning point is of my graph. So let's plug in x values that are to the left of this and that are to the right of this. So which values should we probably use? What are two x values that are to the left of -2? What are the next two? -4, -3. So let's plug those in. So I have the absolute value of -4 plus 2 minus 3. What's -4 plus 2? -2. Absolute value of -2? 2 minus 3. -1. So -4, -1 is one of my ordered pairs. Now let's plug in -3. What's -3 plus 2? -1. What's the absolute value of -1? 1 minus 3. -2. So -3 and -2 is another ordered pair. And then we said -2, -3 was our vertex. So from here, there's two directions I could go. I could either get 2 more points to plug in that are to the right of -2 now. Or, what else do I know about an absolute value function in vertex form? What does that bottom sentence say? Do what? What about x equals h? It's symmetric about the line x equals h. So what's my h value here?
2 is
What's h here? We didn't say 2. -2. So I know my graph is symmetric about the line x equals -2. Do you guys remember how to graph x equals a number? What kind of line is it? It's vertical, right? So it's a vertical line going through -2. So I know my graph is symmetric about this line. So how does that help me get more points on the right? These points over here are going to be the same what from this line? Same distance. So it'd be the same y value, yeah.
It's kind of like a reflection of the line.
Yep. That's what all we're doing is reflecting this half of the graph over x equals -2. Does that make sense? So here's my axis of symmetry. And so all my points are going to be the same distance from this line, just going in the opposite direction. Does that make sense? So how far is this one from this line? 1. So I'm going to go 1 in the opposite direction. How far is this one? 2. So I'm going to go 2 in the opposite direction. And there's the rest of my graph. Does everyone see how we did that? If you don't like that, like I said, just plug in two more values. Plug in -1. -1 plus 2 is 1. Absolute value of 1 is 1. 1 minus 3 gives me -2. Plug in 0. 0 plus 2 is 2. Absolute value of 2 is 2. 2 minus 3 gives me -1. So you get the same ordered pairs, just using a different method. Does that make sense? So there's my graph of G, or F, I mean. There's my graph of F. Questions how we graphed F? Okay, now let's look at G. G of X. Is G of X in vertex form? No, why not? On G of X? Oh, so you're saying there's something multiplied by my X? Yes. So this is not in vertex form because of that 2 in front of my X. Vertex form, I don't have anything multiplied by that X inside the absolute value. Does that make sense? So that is why this one is not in vertex form. So I can just graph it like I'm used to graphing it by creating what? A table of values. So I can still graph it. I just don't have the luxury of having that vertex just yet. Okay? So, let's pick some x values to plug in. So someone give me an x value first to plug in. What? 3? Huh? 2. Sorry, I can't hear sometimes. So plugging 2 in. What's 2 times 2? 4 plus 2? Absolute value 6. 6 minus 3. So I get 2 comma 3. As my first ordered pair. Okay, someone give me another x value to plug in. -1? Is that what I heard? Did I hear someone say 3? We'll plug 3 in next. 2 times -1? -2. -2 plus 2? 0. What's 0 minus 3? -3. So -1, -3. Okay. Now let's plug in 3. Two times 3? 6 plus 2?
8.
Absolute value of 8?
8.
8 minus 3. 3 comma 5. Okay, what's another value I can plug in? -3. Everyone with me so far? See what I'm doing? I'm just picking x values to plug into my function. Two times -3? -6. -6 plus 2? -4. Absolute value of -4. 4 minus 3. -3, comma 1. I'm going to go ahead and erase that axis of symmetry. we can kind of see a V forming. Let's get a couple more points, maybe in between these points that I already have, to kind of help me connect my points. So it's another value we want to plug in. 0. Two times 0. 0 plus 2. Absolute value of 2. 2 minus 3. Negative 1. 0, negative 1. It's already graphed for me. And let's do one more value. What's the last value we want to do? Probably to the left of this point right here. Negative 2. Two times negative 2. Negative 4 plus 2. Absolute value of negative 2. And what's 2 minus 3? Negative 1. Negative 2. Negative 1. So now I've got a bunch of points and I see a V forming, correct? So let's connect my points.
Kind of cluttered.
It is kind of cluttered a little bit. That's okay.
Run to the right one.
There's my graph of g of x. Now that I've graphed the two of these, it wants me to compare the graph of f to the graph of g. So it wants me to pretty much describe what happened from f to g. It's not a vertical stretch. What happened when we multiplied by something inside grouping symbols? It's a horizontal shrink. If you notice, g of x can be written as as f of 2x. Because if I take my f of x and I plug 2x in for x, I get g of x. Does everyone see that? If I replace that x with 2x, I get g of x. So it's taken on this form right here. And we said, what happens whenever we're multiplying by something inside grouping symbols? It's a horizontal shrink by a factor of what? Not 2. This is the one where it's 1 over a. 1 over 2, 1 half. So g is a horizontal shrink.
It also got translated to the right one unit.
By a factor of, does everyone see why it's 1 half? And then what else happened?
It got translated right one unit.
And is a horizontal translation right 1 unit. Does everyone see that? Were those the only two transformations that occurred? Yep. It got shrunk horizontally, and it got translated 1 unit to the right. Any questions on example 3? Everyone good there? Now I took this little snippet from 3.6 when we talked about transformations of linear functions. if we're combining transformations, this is the order we're going to use. That order is going to stay the same for our absolute value transformations. So if we have more than one transformation occurring, we're going to go horizontal translation first, stretch or shrink second, reflection third, and then translation vertically fourth. Okay? So let's keep that in mind as we're doing example 4. Let g of x equal absolute or negative 2 times the absolute value of x minus 1 plus 3. It says describe the transformations from the graph of f of x equals the absolute value of x to the graph of g. So it wants me to describe the transformations that occurred before I even graph it. So what was step 1? Horizontal translation. Which one of these is going to horizontally translate my graph?
That plus 3.
That's a vertical translation there.
Oh, the 1.
The minus 1. Remember, if we're adding or subtracting something inside the grouping symbols, that's going to be my horizontal translation. So g of x has a horizontal translation. Is it right one or left one?
Right 1.
Right one. So G is a horizontal translation, right one unit, followed by, what's next? Use A to stretch or shrink the resulting graph. So am I going to have a stretch or shrink here? Say that again. We're talking about 2 here. That's on the outside of my grouping symbols. So is that a vertical stretch or shrink or a horizontal stretch or shrink? If it was inside the grouping symbols, we just saw that it was horizontal. Correct? Say that again. Vertical stretch, followed by a vertical stretch. What's the factor here? Now, negative 2, the negative does something else. What comes next after the stretch or shrink? Reflection. If the negative's outside the grouping symbols, is it over my x-axis or my y-axis? I hear y. Do I hear any x's?
It's X.
Is it x or is it y? I heard both.
X.
It's the x-axis. If it's on the inside, it's reflected over the y-axis. So followed by a reflection over the x-axis. And then what's the last one?
Then vertically translate K units, which would be that positive.
And it'd be how many units? I'll put that there and insert it there. Did I cover all my transformations? Yes, I did. We got our horizontal one first, our stretch or shrink, our reflection, and then our vertical translation. Okay? So there's letter A describing the transformations from the graph of my parent function to the graph of G. Now it wants us to graph G. Can I go ahead and erase letter A? Give me some room to work. Is this in vertex form? It is in vertex form. So what do I know my vertex is?
Positive
1, comma 3. I know it's going to have a turning point at 1, comma 3. So now let's plug in -1 and 0 to get 2 more points. So if I plug -1 in, what's -1 minus 1? -2, absolute value of -2. 2, -2 times 2, -4 plus 3. -1. So -1, -1. Plug 0 in. What's 0 minus 1? -1, absolute value of -1. -2 times 1, -2 plus 3. 0, comma 1. And then we have 1, comma 3. So, which line am I able to reflect this part over? Where is it symmetric? X equals 1, correct? Symmetric about that line. So I know I can reflect this half of my graph over that line. So I'd get a point there, as well as a point there. And I now have my graph. Like I said, if you don't like that reflecting, you could always plug in 2 and 3, and you would get these ordered pairs when you plug them in. So there's my graph of G. So there's letter B. Questions on example 4? Not too terrible? Can I move on? Here's our assignment. This will be due Thursday on Canvas. Pages 160 through 161, numbers 6 through 40 evens. Get this written down for me. And so I can project the book page up onto the board. 160 through 161, 6 through 40 evens. Does anyone have any questions about the notes before I stop the recording?